Hello, good morning everybody. Today we are going to discuss about Cbse 11th Physics, Thermal Properties of Matter. The first question is, a copper block of mass 2.5 kg is heated in a furnace to a temperature of 500 degrees C and then placed on a large ice block. What is the maximum amount of ice that can melt? Specific heat of copper is 0.39 J G inverse K inverse. The heat of fusion of water is 335 J G inverse. So how do you calculate? First of all, the mass of the copper block is 25 kg m. The temperature of the block 500 degrees C, that is del T. The specific heat of copper C is equal to 0.39 J G inverse K inverse. The latent heat of fusion of water L is equal to 335 J G inverse. So let M be the mass of the ice melted. Therefore, heat gained by the ice equal to heat lost by the copper. So ML is equal to MC del T. So M is equal to, or M dash equal to MC del T divided by L. So 2500 into 0.39 into 500 whole divided by 335. We come to conclusion that 1500 G, that is equal to 15 kg. Then another question, second question is, a 10 kilowatt drilling machine is used to drill a bore in a small aluminium block of mass 8 kg. How much is the rise in temperature of the block in 2.5 minutes, assuming 50% of power is used up in heating the machine itself or lost to the surroundings? So C heat of aluminum is equal to 0.91 J G inverse K inverse. So given என்ன கொடுத்துருக்காங்க, பவர் 10 kilovolt கொடுத்துருக்காங்க. Mass of the aluminium block M is equal to 8 kg. That means 8 into 10 power 3 gram. Time 2.5, that is 2.5 into 60 seconds multiply பண்ணோம்னா we get 150 seconds. So C heat of aluminium C is equal to 0.91 J G inverse 1 K inverse 1. So total energy is equal to P into T. So that is equal to 10 power 4 into 150, that is equal to 15 into 10 power 5 J. Yeah, 50% of energy is used in the heating or lost to the surroundings. So therefore, the thermal energy available del Q is equal to 1 by 2 into 15 into 10 power 5. That is equal to 7.5 into 10 power 5. As del Q is equal to MC del T, so del T is equal to del Q divided by MC. That means 7.5 into 10 power 5 whole divided by 8 into 10 power 3 into 0.91. So altogether we come to n 7.5 into 10 power 5 whole divided by 7.28 into 10 power 3. So final answer is 1.03 in 10 power 2. Rise in temperature of the block del T is equal to 103 degrees centigrade. The another one question is, a thermocol ice bag is cheap and efficient method for storing small quantity of cooked food in summer in particular. A cubical ice box of size 30 cm has a thickness of 5 cm. If 4 kg of ice is put in the box, estimate the amount of ice remaining after 6 hours. The outside temperature is 45 degrees centigrade and the coefficient of thermal conductivity is thermocol is 0.01 J S inverse M inverse K inverse. Heat of fusion water equal to 335 into 10 power 3 J kg inverse. So how do you calculate this? A side of the cubical ice box S equal to 30, Cm is equal to 3 in 10 power minus 2. The thickness of the ice box L is equal to 5 centimeter, 0.05 meter. The mass of ice kept in the ice box M is equal to 4 kg. So time T is equal to 6. H is equal to 6 into 60 into 60, 21,600. Outside temperature T1 is equal to 45 degrees centigrade. The temperature of the ice box is 0 degrees centigrade. The temperature difference T1 minus T2 is equal to 45 minus 0. The surface area of the ice box is equal to 6 into 0.3 whole power squared. So that is equal to 0.54. The coefficient of thermal conductivity of thermocol K 0.01 J S inverse M inverse K inverse. The heat of fusion of water L is equal to 335 into 10 power 3 JkG. So total heat entering the ice box in 6 hours is so Q is equal to Ka T1 minus T2 into T whole divided by L. So 0.01 J S inverse M inverse C inverse into 0.52 M squared plus 450 C into 21,600 S whole divided by 0.05 M. The final answer is 1.05 in 10 power 5 J. Let M be the total amount of ice that melts in 6 hours, but Q is equal to ml. Therefore, M is equal to Q bar L. That means 1.05 in 10 power 5 whole divided by 335 into 10 power 3 is equal to 0.313 kg. So finally, amount of heat remaining after 6 hours 4 minus 0.313, that is equal to 3.687 kg. The next question is, a brass boiler has a base area of 0.15 m squared and a thickness of 1 centimeter. It boils water at the rate of 6 kg per minute. When placed on a gas stove, estimate the temperature of the part of the flame in contact with the boiler. Thermal conductivity of brass equal to 109 J S inverse M inverse K inverse. Heat of vaporization of water 2256 in 10 power 3 kg inverse. So how do you calculate this one? So the base area of the brass boiler A is equal to 0.15 meter squared. The thickness of the boiler D is equal to 10 centimeter. That means 0.01 meter. The brass boiler boils water at the rate R is equal to 6 kg per minute. So time on the T is equal to 60 seconds. So mass on the 6 kg. So the thermal conductivity of brass K is equal to 109 J S inverse M inverse K inverse. The heat of vaporization of water L is equal to 2256 in 10 power 3 joules per kg. So let T1 be the temperature of the flame on contact with the boiler. Let T2 is the boiler point of the water, 100 degrees centigrade. Let Q be the amount of heat of flowing the water through the base of the boiler. So Q is equal to Ka. That means Q is equal to Ka T1 del T2 into T divided by D. So Q is equal to 109 into 0.15 into T1 minus 100 into 60 whole divided by 0.01. That is equation number 1. Heat received by water Q is equal to ml. Up Q is equal to 6 into 2256 10 power 3, equation number 2. Then equating equation 1 and 2, we get ml is equal to Ka T1 del dt d2 into T divided by D. So 6 into 2256 in 10 power 3 equal to 109 into 0.15 into T minus 100 into 60 whole divided by 0.01. So 1356 into 10 power 3 in 01 is equal to 981, open the bracket, T1 minus 100. But T1 minus 100 is equal to 13536 in 10 power 3 in 0.01 divided by 981. So T1 is equal to 1379 plus 100. So the answer is 237.9 degrees centigrade. Therefore, the temperature of the part of flame in contact with the boiler is 237.98 degrees centigrade. Thank you.